This video will discuss what a probability distribution is and what odds are. In a probability distribution, what we're doing is we're going to make a table that lists out all of the outcomes, and for each outcome, we're going to assign it a probability. So, here's how this works. Let's make a probability distribution for the number of heads that occur when 3 coins are tossed simultaneously. So again, we're going to start this off by creating a tree. And when we create our tree, it looks something like this. On the first toss, you can get either heads or tails. On the second toss, if you flip a head, you can get again heads or tails. Likewise, if you flip a tail, you can either get a head or a tail. And then finally, on the third toss, it would branch out like this. Head, tails, head, tails, head, tails, and finally, head, tails. So this is me flipping a coin 3 times. And I'm interested in the number of heads that I can get. So if I write out all of my possible outcomes, I see that the first branch is head, heads, heads, all 3 heads. Next one, heads, heads, tails. That's 2 heads. Next one, heads, tails, heads. That's also 2 heads. Last branch at the top, heads, tail, tail. On the bottom branch, you get tails, head, head. That is 2 heads. Tails, head, tails. That's 1 head. Tails, tails, head, 1 head. And then you have tails, 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 which are no heads. So again, this table that we're going to create is going to list out all the possible outcomes. So the first thing we're going to do is we're going to define a variable. We'll call that variable x. And we'll let x equal the number of heads. And so when I write this out now, I can see in this first, and I know that the minimum number of heads I can have occurs down here when I get no heads. So that means the minimum number of heads is 0. And then the maximum number of heads occurs up here where I get all heads. So the maximum number is 3. And then we have everything else in between because we saw we had 1 head and also 2 heads. So those are the probabilities on the top. Those are all your possible x's. The next thing we're going to associate a probability with each one of those x's. Well, there are a total of 1, 2, 3, 4, 5, 6, 7, 8 outcomes. And out of those 8 outcomes, how many of them end up in exactly no heads? Well, that is only 1 out of the 8 outcomes. In the next one, we see that there are how many outcomes that end in 1 head? 1, 2, 3. So there are exactly 3 out of the 8 outcomes that end in 1 head. How many end in 2 heads? 1, 2, 3. 3 out of the 8 end in 2 heads, and then 1 out of the 8 end in exactly 1 head. 3 heads. So we can verify a couple things here, and we're going to do that. First off, notice that the probabilities are all in between 0 and 1. So no negatives, none bigger than 1. If you add up your numerators, you get 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 1 is 8, that's 8 over 8, so they also sum to 1. So this is what we call a probability distribution, and we can make this for anything that has whole number outcomes, in this case with the number of heads. Now, the other thing we're going to talk about what we call odds, and odds are a backwards way to look at probability. So when we talk about odds, there's 2 types of odds. There's what's called odds for and odds against. And it's all about where you're placing the event of interest. So if you look at odds for, the odds for event A or the probability of A over the probability of not A. And let's do an example to see what that means. What are the odds for getting 2 heads and tossing 2 coins? Let's go ahead and write out the actual sample space again. So we toss 2 coins, we can have heads, tails, first flip. Second flip, heads, tails, or heads, tails. And so when I look at this, I get heads, 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 tails, tails, head, tails, tails. Right? Now, What are the odds for getting two heads when you toss? Well, how many events end in two heads? There's only one. So odds for getting two heads, the probability of getting two heads basically, or the odds of two heads. How many are for two heads? Well, there's only one out of how many that are not? Three. So there's a 1 in 3 chance that you do this. Now we can when I say it's a backwards probability, we know that these two events right here, these are the for events, these are the not events, or the against events. We know that these have to be the entire sample space. So there's a total of 4 events. And if I want to find the probability of getting two heads, then that would be equal to keep the top number the same. That would be 1. Add these two numbers up. 1 and 3 is 4. There's a 1 in 4 chance of getting two heads when you flip a coin twice. Now, what if we were to switch this around and look at the odds against? What are the odds against getting two heads? Well, again, if we want to find odds against, how many events do not favor two heads? Well, we look at it like this. That would be equal to 3 events don't favor it. How many events do favor two heads? 1 event does. So that's 3 to 1 odds. Or if you want to calculate a probability of two heads, that means, remember, this little c means not. So not two heads. Well, how many are against two heads? And how many total are there? Again, you add these up. 3 and 1 is 4, so that's a total of 3/4.